Generating a random number in C# can be intimidating. First, you find what looks to be a simple method of getting a random number, but then you hear people tell you how bad it is and how you should never do that. Then they introduce you to the various sorting algorithms, byte shifting, cryptographic libraries, and more until your head hurts. Now, at least that was my experience. Maybe yours was better. Hopefully. But in this video, I'm going to clear up the confusion and show you just how easy it is to generate the number you need. But before we get started, if you're new to this channel, my name is Tim Corey and it's my goal to make learning C# easier. Whether you're new to C# or have used it for years, you should be able to find something here that will benefit you. Now, if you're interested in getting course discounts or other perks, sign up for my mailing list. The link to do so is in the description. Also, make sure you subscribe to this channel so you can get alerted when I post new content. I post new videos every Monday and Thursday, with occasional bonus videos beyond that. Okay, let's get started. So I have here the Visual Studio 2019 open with the Create New Project. We're going to create a console app with .NET Core, which is one of my recent projects. Therefore, I can just select it over here on the left and hit Next. And we'll call this the Random Number Demo and Random Number Demo App. And hit Create. And the first thing I'll do is I'll remove the console write line for the hello world, and I'll add in my console read line. And I do read line for demos instead of read key, which read key will be any key you press is going to close it, which you can also put before that, like press any key to exit. I do read line for demos because I often have found myself accidentally hitting a key somewhere and my demo goes away. I have to restart the whole thing. So for demo purposes, I use console read line, but maybe for production use, you might find it more beneficial to have read key. It's up to you. Okay, so let's talk about random numbers. And what we're going to cover today is the random class. Let's call it random equals new random. And you've probably seen this, and this is a place that you often start. And in fact, this is the right place to go for about 98% of all your random numbers. So that's what we'll cover today. Now, we're not going to get into, like I said, the more advanced cryptographic libraries like the RNG crypto service provider, which is a lot more complicated, but it does provide a much more randomized number. It's still not random per se, it's more randomized. A random is a pseudo-random number. So what it does is it starts from what's called a seed. And the seed is a value that either you allow the processor to create itself or you pass in a value. So if we don't pass anything in these parens, what we'll do is we'll take the current tick of the clock. And it's going to take that tick and it's going to use that as the number for a random number. So that's a start of. That's not the number it's going to use, as in that's not the number it spits out. It'll use that as what's called a seed, which is the starter value it uses to then calculate a pseudo-random number. Now it's a little complicated, but that's the starter number. The downside of a seed is that if you know the seed, you can guess the random number. I'm going to show that in a little bit. But that's why typically we don't pass in anything for our seed, because we already have a random number that's pretty good. So let's not mess with that. The only thing we're going to be careful of, and this is really tip number one, the biggest tip I can share in this video, I'm going to put it right up front, and that is only do this once. This equals new random, only do this once. The exception would be if you really had to for thread safety, but really, if you're dealing with threading, then what you need to do is convert the random value into a thread safe version of itself. Okay, so let's just generate a random number and see what it looks like. In fact, let's do 10. I'm going to do a for loop from I, 0, I is less than 10. I'm going to say console write line random dot next. And that's a method. And you can pass a value in. We're not going to yet. I'll show what that does. But for right now, we'll just say, hey, give me 10 random numbers. And let's run this. And this is the values we get back. Okay, so that's 10 random numbers. Notice they're whole numbers. And the first one starts with 318. Let's run this again. And notice the first one is 104. So these are randomly generated. If, however, we wanted to limit these and say, you know what, I want from 0 to 10, I'd pass in an 11. And the reason why 11 is because we have the upper range, the max possible value, will not get picked. So this is saying it starts at 0, so I didn't have to pass anything in. So the max value I'm passing in is 11, which is, so everything's going to be less than that max value. If we run this again, now our numbers are 9, 0, 10. So that's our range actually right there, is 0 to 10. If we want to be a little more clear and say, you know what, I actually want a value between 5 and, let's just say between 5 and 10, we say 5 and 11. So minimum value can be 5, but it's less than 11. So greater than or equal to 5, less than 11. If we run this, since we're doing a loop 10, we've got this list 7, 8, 7, 10, 5, 8, 7, 10, 9, 7. So this is going to be inclusive of 5, but notice no 5 is here. It's random, so it doesn't always going to be. Let's actually run it again, make sure there's going to be a 5 at some point. There you go. There's a 5, a couple of them. So it goes from 5 to 10, but there is no 11s. And that's because it's less than our max value. Now remember I said that if you pass in a seed, let's just say you pass in 1 as our seed number. If that seed number is known, we'll know what the values are going to be. Let's test this by running it twice. So 6, 5, 7, 9. Run it again. 6, 5, 7, 9. That's because our seed number was the same. And that's where the danger comes in with using your own seed number, is if that number is known, then we can recreate every random number from then on out. Now, this is where people start panicking and saying, okay, we need to have this cryptographic library and yada yada. Don't panic. If you are writing something that has to be absolutely random, then yes, the cryptographic library is the way to go. That typically is for passwords. That's where you find most of this occurring. If we're talking about shuffling a list or generating a random age for a person or stuff like that, we don't have to worry about it. And the reason why is because we don't often get the need for absolute randomness. If we use the tick value, which ticks are the number of, I believe, 100 nanosecond intervals from the year 1, day 1, so January 1st, 0001, through now, so that's a count of them. So that number is always changing, and it changes every 100 nanoseconds, which that's a lot. So the idea that you're going to get the same exact tick, the only case that would be is if you put this right here where it generates that tick value and uses it. If we put this multiple times inside a loop, there's a potential for us to have repetition at that point. But that's why I said right up front, only do this once, and for everything else, call next. Because that gets the next random number off of this random number. So therefore, at this point really close to truly random. We're not truly random, it's still pseudo-random. I'll be very clear about that. But at the same time, you can definitely use it for almost every case. So let's see how to use random well. Well, first of all, like I said, call next. Don't do this. Call next and you're safe. So you might want to pass this around your application. And in fact, if a method needs a random number, so we have a private static, let's just call it simple method, and it's going to get a random number. Well, you say, well, I could do a random, and no, don't do that. Instead, pass in the random method. That way, right in here, you can say random dot next, like so. Oops, say void. And there, now you can call this as many times as you want, like so. And let's just comment this out and just say simple method, like so, and we pass in our random. And now it's using the same random version, and it's doing the next on it, it's not reinstantiating it. Therefore, now when I run this, there's our random numbers. It starts with 1602. If we run it again, we get 9201, not the same number. So now we can pass this around. Again, just be careful about thread safety because this is not a thread safe instance. So you have to wrap it in a thread safe wrapper. But again, that's probably not something you'll do often. It's only if you get into passing around with the asynchronous methods maybe that you might want to consider that. Okay, let's look at other things you can do with the random number besides just we already covered, which is just a random number, which is a random integer, limiting it to just the maximum, like that, or putting a range around it, lower to less than upper. We can also do, let's comment this line out, and we'll do a console write line here and say random dot next double. You can't pass a value in here. So it's going to give you a value between 0 and less than 1. That's what next double gives you. And if we run this, you'll see there's our, basically it throws a decimal in front of that number it generated before. Well, how does that help us? Well, if you want to generate a double and you want it to be random, what you could do is say, well, I want it to be start at 0, but max to be, 10. You could say times 10, and then you'll get values that are between 0 and less than 10. It's not going to be 10 flat. It's going to be 9.9999. But you will get doubles that are within that range, 0 to 9.999. Okay? So that's how you can get doubles with it as well. So there's some really valuable things you can get with random numbers, whether it's as simple as generating a person's age or more complex like sorting a list. Let's look at that. And this is one of those that's going to be a struggle for some people because it is not the most performant, which means if you have a list of thousands of items, don't use this sort method. But if you get a list of 75, 100, 200 things in a list, or 50 or 10, then it's not a problem to use this method, and it's practically random. So let's create a quick class here. I'm going to create a class because I want to show off the fact that it can use objects. So public class, we'll use our standard person model and I'm going to give it just a first name. Okay? We could do last name as well and all the rest, but it's just quicker to do it this way. So now up here, let's comment out everything after random and start over again. And I'm going to create a list, which we don't have list added to our using statement yet, so I had to add it. list of person model. The reason list is not up there is because I have no using statements except for system. So we have to add all the using statements we need. And that's how .NET Core does it, just be a little bit more clean. I'm not sure I'm a big fan or not. I like to have some of the standard ones there and remove them because it's a little easier for me to do, but that's fine. So a list of person model, call it people, equals new list of person model. Whoops, use my curly braces here. And then I'll put my semicolon. I'll say new person model, first name equals Tim. And then new person model, first name equals Sue. And let's copy this a few more times just so we have some options here. There we go. There's some random names. I choose short names because they're just easier to type. So now we have a list of people, and it's in this order. I'm not a big fan of this order. And I could do something like I can order it by first name if I wanted to. And I can do a for each here and say P in people, and then do our console write line P dot first name. So I can do an order here first and say, well, I really want this to be in alphabetical order, and that would be something like people dot order by control dot, add the using link statement. I can say order by and then x dot first name. That's how you order by first name. Just want to kind of establish our baseline first. But notice it does return a order by returns a new I order enumerable. So you could say var sorted people equals like so, and then loop through those just to show off that it can in fact sort this appropriately. Bob, George, James, Mary. These are in alphabetical order, starting from B from Bob and going to T for Tim. However, what if you wanted to shuffle this list instead of sorting it by a certain person? Well, instead of ordering it by first name, which is what we're doing here, we could say random next. So you see what's doing there? When we passed in first name, it said use this as the comparison to figure out if Sue goes before Tim or not, and if Mary goes before Sue or not, and so on. It kind of reshuffled it. Now, the way it does it, like I said, is not terribly efficient, but this is pretty quick. And so if you have something quick to do, this is the way to go about it. So instead of passing in that first name to be the one that compares, we're just comparing it on a number, a random number. And it's always next, which means it's always the next random number, which means it's not the same value. That means if I run this, it starts at Tim and ends at George. Let's run it again. It starts at Jane and ends with Tim. And if you run it again, it starts at Jane but ends at George this time. So it's reordering this list every time in a random way. Now, just to kind of show off again one last time, if I pass in a seed value, it's from Sue to George. And if I run it again, it's from Sue to George. So you really do be careful. Don't have it pass in a seed value. Don't put this right here inside of your list somehow, or your loop. All right. So with that being said, now what we have is a quick way to shuffle a shorter list. Now, there are ways to get into the larger list shuffling. And let me just show you really quick. This Stack Overflow post, which I will link in the source code, this shows you how to do a randomized list of T. You'll see two different takes on this. One is something like this, and the other is something more like this. Now, this one, not a great method, and the reason why is it's ordered by a GUID. GUIDs will be unique, but not necessarily random, and that's what this is pointing out here. So, ordering by a GUID, not always the best idea. But it's the same basic method we're doing with the order by. It's just we're ordering by a random number, they're ordering by a GUID instead. But here is the more classic Fisher-Yates shuffling mechanism. And this is why if you want to shuffle something randomly for sure, this is going to be helpful. It is going to help you do it, but it is going to be a bit more tricky. Now, this person uses unchecked tick count and managed thread ID. I wouldn't go there. I would go with the RNG crypto service at that point. But what they're doing, and this is shows you how to do all of that. What this is doing is it's using this Fisher-Yates shuffle, which is a more efficient shuffle mechanism. If you have thousands of items in your list, yep, that's the way to go. So I'll link to this. But in general, if you are shuffling just a moderate sized list, then this method right here is a whole lot simpler and it works. It's not going to be, like I said, the most performant. If performance is key and paramount, then yes, by all means, adjust your thinking. But with this, it will get the job done. It will get the job done fairly quickly, just not as quickly as possible. Okay, so sorry to have so many caveats here, but that's what random numbers are all about. And if you've heard all those caveats and you've heard well, don't do this, and you have all these different opinions, I'd say come back to this. Start off with a random that you don't pass a seed value in. Don't try and improve on the tick. Don't pass a seed value in, and then always do next. And that will serve you for almost every case. If you have to go beyond that, I will put let me grab it right here. I will put right up at the top, and I'll also put the RNG crypto service provider demo, because it has both in there. So that's the more advanced if you need it. But in general, stick with the simple that you can maintain, that's easy to understand, and that gives you a pseudo-random number that is fairly close to totally random. All right, so that's random numbers. In a shell, it's very simple. It obviously can balloon up over time, but hopefully this kind of simplified things for you and made you feel a little bit more comfortable about using just random. All right, thanks for watching, and as always, I am Tim Corey.